Today's class I am going to discuss about how to write design and test bench Verilog HDR code for 4x1 multiplexer. So let me start from the block diagram. It's a simple block diagram of 4x1 mux. It's a 4x1 mux block diagram. It has a 4 inputs. It has 4 inputs that namely called as D0, D1, D2, D3. Then it produces one output that namely called as Y. So these two lines are called as selection line S1, S0. What is the basic operation of 4x1 mux? So based on the selection line, the input value is mapped with output. Here the selection lines are two variable. It makes 4 combinations of input 0, 0, 0, 1, 1, 0, 1, 1. So this is the output response. If both the selection lines are set to be 0, both the selection lines are set to be 0, D0 is mapped with output. So whatever value present in D0, that value is mapped with output Y. So Y equal to D0. Next case 0, 1. 0, 1 means D1 is mapped with output Y. So Y equal to D1. Likewise, selection line 1, 0 means D2 is mapped with Y. Then 1, 1 means D3 mapped with output Y. So this is the basic operation of 4x1 mux. Now I am going to write the design program. So design code for 4x1 multiplexer. So first you write module followed by module name. Here module name is mux underscore 4x1. So it's a module name. Then declaration of input and output variables for this 4x1 mux. So in this block diagram we have 4 inputs. So D0, D1, D2, D3. We declare as vector format. So 3 down to 0 D. So this D variable consists of 4-bit value D0, D1, D2, D3. Then selection line also another input. So it's also declared as vector 1 down to 0 selection. Then Y represent as output. So input Y here 3 down to 0 D. Then another input is selection line input wire 1 down to 0 selection line. Then finally you declare the output reg Y. So first you write module followed by module name, then declaration of input and output, then always at start begin, always at start begin. So in this program I am using case statement. Case name is selection. So based on the selection line, the input variable is mapped with output Y. So here we follow the 4 case. So first case is both the values are set to be 0, 0. Next case 0, 1, 1, 0, 1, 1. So based on the case value, the input variable is mapped with output. 2 tick B 0, 0 Y equal to D0. So first case selection line value S1 and S0 both the values are 0, 0. Output Y equal to D0. Then next case 2 tick B 0, 1 output Y equal to D of 1. Then 2 tick B 1, 0 Y equal to D of 2. The last case 2 tick B 1, 1 Y equal to D of 3. If the selection line value is not matched with these 4 cases, it considers default. So default y equal to 1 tick we don't care. If the selection line is not matched with this 4 combination, the corresponding output is considered as don't care value. Then end case, then end. So design code stop with end module. So design code end with end module. So this is the simple design program for 4x1 multiplexer. Now I am going to write test bench code. So as usual you write module, then module name tb underscore mux. So tb underscore mux is the module name. So in design code, input is declared as wire, output is declared as reg. But test bench code, input declared as reg, output declared as wire. Reg 3 down to 0 D, then reg 1 down to 0 selection, then wire y. The next step, declaration of instantiation. Marks underscore 4x1. So this term get from design code module name. So design code module name is marks underscore 4x1. DUT represent design under test. Dot D comma dot selection line select comma dot y. So it's a format of declaration of instantiation. Then initial begin dollar dump file mux dot vcd, then dollar dump was 1. So these two statements are used to get in the waveform while you run the code on EDA playground 2. EDA playground. So while you run the code on EDA playground, you can use these two statements to find the waveform. Then dollar monitor. So this statement help to monitor the input variables value and output values. So t equal to percentage 0t comma d equal to percentage v comma selection equal to percentage v comma y equal to percentage v, then dollar time comma d comma selection comma y. So it's a monitor statement. Next, now assign the d value d equal to 4 tick b 1010. So d value it consists of 4-bit value. So it's represented as binary. So here I meant 4 tick b 1010. Now the selection line value equal to 2 tick b 00. So here let me consider d value is 1010. It consists of 4-bit value. This LSB bit name called as d of 0. This value call it as d of 1. Second bit represent d of 2. MSB bit represent d of 3. So here first case is selection line equal to 2 tick b 00. So 2 tick b 00 means d naught is mapped with y. Here d naught value is 0. 0 value is assigned to y. Expected output. So in this case y equal to d of 0. So d of 0 value is 0. So 0 is assigned to y. So after 5 time cycle, again Let me consider the D value, same value, 4 tick B 1010. But selection line value may be changed from 00 to 01. 2 tick B 01. Then after 5 nanosecond, again change the selection line. So now selection line value is 01. 01 means D1. So D1 is mapped with output Y. D1 value is 1. Y equal to D of 1. D1 value is 1. So this 1 is assigned to Y. So after 5 seconds, again I take the same value for B, for D. 4 tick B 1010. Now the selection line value is 2 tick B 10. So 10 means output equal to D2. So D2 is mapped with output. Y equal to D of 2. D2 value is 0. 0 is assigned to Y. After 5 time cycle, D equal to 4 tick B 1010. Selection line equal to 2 tick B 11. Now Y equal to D of 3. The last bit D of 3 is 1. So this 1 is assigned to Y. So D3 is mapped with Y. So after 5 time cycle, $finish the function, end, then end module. So I hope you understand the concept very well. If you are watching first time in my video, kindly subscribe and support us to make a lot of videos.